Okay, this is section 8.1 part 2 where we are translating algebraic expressions. So like taking a written out description and making it algebraic or vice versa. And then also modeling real world situations with algebraic expressions in a variety of representations. The pictorial and symbolic is mostly talking about algebra tiles. Okay, so we'll see some of those. Okay, so when translating verbal phrases, there's sort of some key phrases or words that tell us what operation is going on. So that's what we have in the first column. When we're talking about addition, you might hear sum, plus, total, more than, or increased by. And for two examples, we have the sum of 2 and a number x, or a number n plus 7. And so the first one translated to 2 plus x, and then a number n plus 7 is n plus 7. For subtraction, keywords are difference, less than, minus, and decreased by. So for example, the difference of a number n and 6 is n minus 6. For some reason, that one tends to confuse people, so my rule of thumb is always just go left to right. So n minus 6. And then for another example, a number y minus 5. So that's just exactly what it sounds like, y minus 5. For multiplication, some keywords are times, product, multiplied by, or of. So 12 times a number y is 12y. 1/3 of a number x means that you are multiplying. So that's where the of comes from. That's 1/3 x. Now for division, some keywords are quotient, divided by, or divided into. So for example, the quotient of a number k and 2 is just k divided by 2. Okay, example 1. Translate 2y plus x cubed into a verbal expression. So the sum of 2 and y plus the cube root of x. Remember, cube root means like that, so it can't be a. The product of 2 and y plus the cube of x. The cube of x looks like that, so that is what we're looking for. But let's double check. So the product of 2 and y plus the cube root of x, nope, can't be that. The sum of 2y and x raised to the third power. Okay, so this is where you got to be careful, because the sum of 2y and x raised to the third power, well, that looks like what we're looking for. The product of 2 and y plus the cube of x is technically 2 times y plus x cubed. Okay, so there's a difference there, because if you were to distribute the second one, it would be 2y plus 2x cubed. So that's what makes it D and not B. And that's something you sort of just have to practice. Example 2. Select each phrase that verbally translates this algebraic expression. Okay, so remember, this tells me that I'm going to be picking more than one. So the cube root of y minus 2x. So 2 times x, subtract the cube root of y. That is backwards, so that's not right. The cube root of y less 2 times x. Okay, that is going to be one that we pick. When it says less, remember that means you're taking away. So if I said like 5 less $3, that's like taking away $3. So minus 3, or minus 2 times x. 2 times x less than the cube root of y. That is also correct. Okay, so you have the cube root of y and 2 times x less than that. So you're going to take away 2 times x. The cube root of y less than 2 times x would be 2x minus the cube root of y. So it's not the last one. So it's just the middle two. But remember, when you have to select all that apply, you have to pick both or the whole problem is wrong. Okay, example 3, pictorial models. So here's our key that tells us what the different algebra tiles mean. And then it says which expression is represented in the model. So if we look up at our key, the white rectangles stand for x. So I have 4 x's there. And then if I have dark squares, that stands for a -1, so that means I have -3. So if I look down here, I am looking for 4x minus 3. Okay, example 4, situational models. Now, I can't show you an example of every different situation because there's just so many different ones that it could be. But in general, we're just looking at a word problem, a story problem, a real-life example that we can model using an expression. So, for example, Jessica is 3 years more than 5 times her sister's age. If her sister is y years old, which expression describes Jessica's age? So, in other words, so if I have y, and we said 3 years more, that's got to be plus 3, than 5 times her sister's age. So 5y plus 3 is C. And you could test it just to make sure. So maybe Jessica's sister is 2. So let's say y is 2. So 5 times 2 is 10, plus 3 is 13. So in other words, 3 years more than 5 times her sister's age. Well, 5 times 2 is 10, plus 3 more years is 13 years. Okay, example 5. Jefferson Middle School earned $800 in ticket sales for a play. The cost per ticket was $5. Which of the following equations could be used to determine how many tickets were sold to the play if T represents tickets? Okay, so whenever you have total and then a rate, so like $5 a ticket, in general, you're going to want them on the opposite sides of the equal sign. So if I look down here, that eliminates that one and that one, because 800 total times $5, that's not going to tell me how much a ticket cost. And then $5 equals $800 times every ticket. That doesn't really make sense either. But here I have $5 times the number of tickets sold equals $800 total. So that makes sense. But down here, ticket equals $800 minus 5. A ticket's not going to cost $795. So C is the only one that makes sense in this situation. Again, I can't show you every different situation, but it's just to give you an example of how we can model these situations using expressions and equations. And that's it for this section.